Welcome to homework.
So we have defined the pH of 0.65 molar of potassium formate. And from the other source, I find that the pK of methyloric acid is equals to 3.7. Okay, first of all, we're going to separate these compound into two different parts. So we have formate ion and also potassium ion. So for this case, only formate ion will go into react with water, and it will act as a base. So I will have a B minus with water, and then we will produce HP or BH, this doesn't really matter, and also with our hydroxide ion. So again, we can set up the ice table. So we have 0.65, and then we have minus x, so 0.65 minus x, and then we will have 0, 0 plus x, x, and x. And the k, we're looking at the base, so we have kb. The kb expression will equal to x squared, 0.65 minus x. Okay, so because we are given the pKa, we have to find out the kb. So the pKb can be found by 14 minus our pKa. So with 14 minus 3.7, we should be able to find that as 10.3. In other words, kb will be equals to 10 to the power of minus 10.3. Okay, so if we actually look for the actual number, you should have 5.0 times 10 to the power of 11. So again, because we have a really, really small kb, so in other words, x will be a very, very small number. And also, when compared to the initial concentration, it will be insignificant. So in other words, we have x squared divided by 0.65, simplified like that. So x, which would be our concentration of hydronium, equals to square root of 0.65 times kb. So we are going to solve for that. And we should be able to find that x should be equals to 5.7 times 10 to the 6 molar. All right, so because we're looking at the hydroxide concentration, so we can convert the hydroxide concentration to pOH. So we just need to take a left log of our hydroxide concentration. So we just left log of the value of x, and we should be able to find this 5.2. And again, pH, we are going to take 14 minus 5.2, and then we should be able to find is equal to 8.8, and this will be the pH value of the solution. Okay, so part B of the question is we have to find the 0.8 molar of ammonium bromide, the pH of this solution. And I find that the Ka of ammonium ion will be equals to 5.8 times 10 to the left 10. So for this compound, separate that we have ammonium ion or also a bromide ion. So if you can see that only ammonium ion is strong enough to dissociate to in water to form a hydronium ion. So essentially, we will have our ammonium ion with our water, and that's going to form ammonia again, and then with our hydronium ion. Okay, again, we can set up our ice table. So we have 0.85, and then 0.85 minus x, and then we have a 0, 0. We have x being produced, and then our Ka will be equals to our x squared divided by 0.85 minus x. And again, the Ka is very, very small because it's 10 to the power of 10. So the x will be small and also insignificant when compared to our initial concentration. So we can simplify our equation by taking out x and in the denominator. And then this should be equals to our Ka. Okay, so x should be equals to our square root 0.85 times Ka. So we have 0.85 times 5.8 times 10 to the left 10, and then square root of it, and then we should be able to find that is equals to 2.2 times 10 to the left 5 molar. And x essentially is the concentration of hydronium. So therefore, pH, we are going to take like a log value of our x, And then we should be able to find roughly around 4.7 for the pH value.